Now that we have finished the vertical axis of rotation, we will start doing the horizontal axis of rotation. This is pretty much the same thing as the vertical rotation, except everything is in respect to y instead of x. And we kind of changed the limits. Instead of a to b, it's c to d. Here's the graph, a general graph of how the horizontal axis of rotation would be. So now let's try a problem. Sketch the region bounded by y equals to x, y equals to 5, and x equals to 0. Use the shell method to find the volume of the solid generated by revolving the region about the x-axis. To save some time, we already have the graph ready. We know that this problem is a horizontal axis of rotation since it's revolving around the x-axis. And so this means that it will be in respect to y. As we already know, p of x is the distance from the axis of rotation to the center of the rectangle. And in this case, we know that it's in respect to y, and we would just call this y. As for the height, it's not really the height, honestly, it's more like a length, but the height, since you see this rectangle is touching the function here, it would just be x, or actually it's y because it's in respect to y. And so now, since we have the radius and the height, we still need the limits. And as you can see from this graph, the lowest y value we can have is 0, and the highest y value we can have is 5. And therefore, our limits will be from 0 to 5. And so here we have the integral v equals to 2 pi times the integral of y times y dy from the interval of 0 to 5. And here on the bottom we have simplified the y times y, which is just y squared. And after that, all we have to do is just integrate. And as like before, you guys should know how to integrate this by now.